Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Who would have thought that waste, often being considered worthless by many people, could actually become an innovative solution to this world? In this research, we are going to explore the fully potential of hybrid composite made by water hyacinth and grass waste as brake pad material for motorcycle.
Through this approach, we aim to prove that natural fibers and wet material can serve as an eco-friendly yet effective alternative. Let's dive into how this research can open new opportunity in the world of automotive material.
This is our product, namely Arta, innovation in making environmentally friendly brake pad from water hyacinth
And broken glass waste with an epoxy resin matrix.
My name is Bre Arka Bima Putra,
My name is Bima Putra,
and we are from Mantu KUDUS. Indonesia is one of the countries in Asia with a high rate of motorcycle usage. Traffic accident data from 2014 show that 72% of road traffic accidents involved motorcycle. One of the key factors contributing to accident is brake failure. The main component in this system is the brake pad. Brake pads are generally made from asbestos, but their use has negative impacts on the environment and health. This study aimed to determine the characteristic of brake pad made from water hyacinth and glass waste with an epoxy resin matrix. Indonesia has an incredibly rich biodiversity. One of the plants commonly found in the country is water hyacinth. Currently, water hyacinth is still considered as a pest due to its rapid growth, which often causes problems in downstream river or swamps area. During period of high rainfall, water hyacinth are carried by river current to downstream area, where they accumulate and overpopulate. Their rapid growth can even cover the entire surface of river or swamp. We chose water hyacinth as a filler material in this composite due to its chemical composition, which includes cellulose by 18 to 31%, lignin 7 to 26%, hemicellulose 18 to 42%, and ash 15 to 26%, with a moisture content reaching 85 to 95%. The relatively high cellulose content in water hyacinth serves as a reinforcing agent in the production of this composite. Seeing the issue before, this research proposed an innovative brake pad made of composite material utilizing water hyacinth fiber and glass powder as filler, reinforced with an epoxy resin matrix. The use of water hyacinth as a natural fiber provides wild flexibility and friction resistance. Glass powder offer advantage in unchanging hardness and heat resistance. This combination of material is expected to produce a more environmentally friendly brake pad with optimal performance and serve as a solution to Indonesia's waste problem. And these are the tools and material that we are going to use. Production of glass waste powder. Glass powder is obtained through the mechanical crushing of glass waste. The crushed glass is then sieved to obtain a powder with a 60 mesh size. Preparation of water hyacinth fiber. First, mature water hyacinth plants are selected. The plants are then crushed until the fibers become visible and subsequently soaked for chemical treatment. To neutralize the chemical property of NaOH, the fibers are rinsed with clean water and then placed in an oven at a temperature of 85 Celsius to 100 Celsius for an hour. Once dried, the fiber are manually decorticated until clean, revealing a single strand of fiber. Production of glass waste powder. Glass powder is obtained through the mechanical crushing of glass waste. The crushed glass is then sieved to obtain a powder with a 60 mesh size.
Density test. The density test reveals that a higher glass powder content increases the density, with F5, which is 30% glass powder, and 0% water hyacinth, reaching 1.321. closest to the SAE G661 standard. Meanwhile, F1, which is 30% water hyacinth and 0% glass powder, has a lower density at 1.153 due to the lightweight nature of the natural fiber. Although higher density can unchain strength, excessive glass powder may lead to brittleness and increased wear, whereas water hyacinth fiber create a lighter but potentially less pressure-resistant material. Heat resistant tents. The heat resistance test shows that F4 composite, 15% water hyacinth and 50% glass powder perform the best, experiencing only a color change without surface damage. This indicates an optimal balance between heat resistance and structural stability. Water hyacinth fiber are rich in cellulose, exchanging composite strength, but they are vulnerable to high temperature. In contrast, glass powder improves the thermal resistance. F1, which is 30% water hyacinth and 0% glass powder, shows more discoloration due to the absence of glass powder. F3, which is 10% water hyacinth and 20% glass powder, suffers total damage due to the material imbalance, while F5, which is 0% water hyacinth and 30% glass powder, remains strong because of the dominance of the heat-resistant glass powder.
Microscopic analysis test. Microscopic analysis from the impact test reveals difference in material structure across specimen. The distribution of water hyacinth fibers and glass powder affects density and compactness. F1, which is 30% water hyacinth and 0% glass powder, appears less compact with visible gaps. F2, 20% water hyacinth and 10% glass powder, is more compact but not fully solid. F3, 10% water hyacinth and 20% glass powder, gains density but loses flexibility. F4, 15% water hyacinth and 15% glass powder, achieves a balanced structure, while F5, 0% water hyacinth and 30% glass powder, is highly compact but prone to cracking. All samples show bubbles due to the uneven mixing, and color variation indicate fiber distribution, with water hyacinth dominant samples appearing darker. The impact test results show that formula F3, which is 10% water hyacinth and 20% glass powder, has the highest impact resistance at 0.025 kJ, while formula F5, which is 0% water hyacinth and 30% glass powder, has the lowest at 0.01375 kJ. The wear test results indicate that formula F1, which is 30% water hyacinth and 0% glass powder, has the best wear resistance with a value of 0.0087 mm, whereas formula F5 experienced the highest wear at 0.2809 mm. A higher glass powder content increased hardness but reduced impact resistance and accelerate material wear. Based on the result of testing the characterization, the F1 formulation, which is 30% water hyacinth and 0% glass powder, is the best brake pad because it has the second highest density and impact test value compared to the other sample. It's resistant to high temperature and has the best wear resistance. Innovation is not always about making something that is new. It's about transforming what already exists into something better. Through this research, we have demonstrated that natural fibers and waste material that have often overlooked can be engineered into a sustainable and effective alternative for brake pads.
This is not just a breakthrough in material science. It is a step toward a greener future in the automotive industry. Let's continue to explore, innovate, and challenge the boundaries of what's possible, because the solution to tomorrow's challenge might just be hidden in today's waste.